Hey guys, today we'll be starting a new topic, which is chapter 4, which is probability. Now, remember, probability is all about the chances of things happening. Okay, so we'll be talking about the chances of events that are happening. So first we're going to be going over a quick review of probability. And we start by talking about theoretical probability. And you can read there that the theoretical probability of an event on which outcomes are likely is calculated as the following. So the probability of an event is the number of favorable outcomes divided by the total number of outcomes. Now, that might sound confusing, but let's look at an easy example. So I've got the word isolation, and I want to know what's the probability of me choosing the letter T out of this word isolation. So we'll pretend that the letters are all written on a piece of paper and they've all been put into a bag and they've been mixed up. And what's the probability of me choosing the letter T out of all those letters? Now, first we want to know what's the number of favorable outcomes. So how many T's do I have in this word? And I can see that I have one T out of this. And now what's the probability? What's the total number of outcomes? Well, that's the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 1 out of 9 chance of choosing a T. What about an O? Well, we can see we've actually got 2 O's. So the probability of choosing 2 O's, I'll just do it over here, is 2 out of. Now I've still got 9 as my total. Okay. Now, what's the probability of not an O? Well, they're all the letters that are not O's, which would be the opposite of this. If there's 2 O's out of 9, then there's got to be 7 not O's, 7 letters that are not O's out of 9. Okay. Now, I could choose a T or an O. Now, we know that there's 1 T and we know that there's 2 O's. So together we've got 3 out of 9. Now, the probability of choosing a T or an O is 3 out of 9. I can simplify fractions down. And in this case, I can simplify this fraction down by dividing the top and the bottom by 3, which gives me 1/3. What's probability of choosing a vowel? Well, that's A, E, I, O, U. So we look at all the vowels here. I, O, A, I, and O. 1, 2, 3, 4, 5. So this one I have a 5 out of 9 chance. Okay. Now remember, you can pause the video if you want to be writing these down with me. We'll go to some more examples. Now, theoretical examples, which is what we were talking about back here, is in theory, what's the probability? But we know if we do something in practice, if we actually went out and chose letters out of the word isolation, it wouldn't always come out to be 5 out of 9 times, say, for a vowel. Sometimes it might happen more. Sometimes it might happen less if I chose 9 times, okay? So we have this thing called experimental probability. And the experimental probability is calculated the same way, but we use the results from an experiment, okay? So I've got an example here. Bored in isolation, someone decides to run an experiment which involves tossing 3 coins and counting the number of heads. Below are the results after running the experiment 100 times. Wow. This person's got a lot of time on their hands. So here we have a table. So you can see 11 times they threw 0 out of 3 heads. 40 times they got 1 head. 36 times they got 2 heads. And 13 times all 3 coins showed a head. Okay? Now, are those numbers exactly what you would expect in theory? Perhaps not, but that's what happened in this experiment. So according to this experiment, how many times did 2 heads occur? Well, we can just look at this number here, 36. Now, it's not a probability yet. It just says how many times. So we don't need to write it over any number as a fraction. How many times did fewer than 2 heads occur? Well, that's just 1 head or 0 heads. So we can know that that's 11 plus 40, which is 51. Now we're finding experimental probability. So now we need to write this as a fraction. How many times did we get 0 heads? Well, that's 11. But now, sorry, it's not how many, it's what's the probability that I got 0 heads. According to this experiment, it was 11 out of my total, which is 100. So 11 out of 100. How many times did I get 2 heads? Well, that is this one here, 36 out of 100. Now I know this fraction can simplify down. If I divide the top and the bottom by 4, I'll get 9 over 25. Okay. What's the probability of getting fewer than 2 heads? Well, fewer than 2 heads was what we did before, this one plus this one, which was 51. So we got 51 over 100. That's the probability of getting fewer than 2 heads. And at least 1 head. Well, at least 1 head is getting 1 head, or 2 heads, or 3 heads. So we need to plus all those together. Which equals 89. And then our probability of getting that is 89 over 100. So that's our probability of getting at least 1 head. Okay. Whoops, I've written in the instructions. So we'll just squeeze this one down here. All right. That should be enough to get you guys going. Exercise 4A in your textbook, or the maths-based task 4A review of probability. Thanks.